Carbon is extremely important chemical element. No carbon, no life. The question is, what is the origin of carbon? The common wisdom is that carbon is produced in the interior of stars. The three alpha particles come together, fuse, and produce carbon, the so-called triple alpha reaction. Recently, there was an idea when the three alpha particles come together and there is a stray neutron around, that neutron can pick up all that energy, remove that energy from the system, and then these three alpha particles collapse to the ground state of carbon-12. The cyclotron provided a unique detector, which is called a Texas active target. Active target detectors have never before been used with neutron beams. We are now testing this interesting idea if carbon is actually produced through this neutron-assisted enhancement of that triple alpha process.
The way that TexAT works is essentially a big aluminum box, and what we do is we fill it with some sort of gas. So in this particular experiment, we wanted to use carbon dioxide gas because we're interested in studying the carbon inside of it. When you have a nuclear reaction take place inside of the gas, you have charged particles which fly off in a particular direction. As these charged particles pass through the gas, what they're doing is they're losing energy. And what this does is it creates electrons and holes inside of the gas as they pass along before stopping. What we can do then is we can use an electric field to basically drift those electrons up to a particular part of our detector called the micromegas. And what this allows us to do is basically get an entire 3D understanding of exactly where all of these particles are traveling inside of the gas. And this allows us to reconstruct this nuclear event.
I think one of the important things would be to just get more statistics for some of the neutron energies that we've already looked at, and also maybe do some smaller energy steps in between so we can try to map out the cross-section. I always just find it very interesting to see what you can do with neutron-induced reactions, specifically because it's just not something you can do every day.
Our experiment will provide experimental data and actual measurements for the process, which was theoretical. We did not know what the probability was for that nuclear reaction to happen in stellar environment, and now we do, which means that now we have experimental constraint on the enhancement of the carbon production in stars due to this exotic process.